If you've ever been to the upper Midwest, this is probably a familiar sight, or a familiar experience. Especially in the morning, you can go waddle out and go plug in both your tractor and your car because there could be a little bit of snow that's out there, or maybe it's freezing cold and your car won't even start if it's below zero. And if you're like me, you've got one of these old school rust bucket trucks that you absolutely adore. Because I mean, where else could you find a truck with manual crank down windows, manual locks, manual transmission, manual four-wheel drive, cruise control, and with 290,000 miles, it does not like to start in the morning. With both the truck and the tractor having block heaters, it is an absolute pain in the butt to go out there to plug them in, then go back inside, come back outside, start them, go back inside, then come back outside to go leave again. We need to make this simpler, and the way to do that is to automate it. So before we get into most of the nitty-gritty, let's give a little bit of an overview about how this whole thing works. The main idea here is going to be to have the Falco server talk to the Controllino, and that's going to happen, of course, over the RS-232 and RS-484 LoRa modules. Now, the Controllino will have a 24 volts power supply powering both the LoRa and the Controllino. Digital outputs will be connected to the relay board that I have shown before. This will control the 120 volt AC mains and will basically turn on and off the heater. Now that we understand kind of how this basically works, let's look at the individual components. I chose to go with a PVC junction box as my cabinet, mainly from the fact that it is completely watertight and it has a thick plastic enclosure. Many of the professional level ones that offer this same compatibility will run you in the hundreds of dollars as compared to this one, which you can find at your local hardware stores. Next up is the power supply, and I wanted this power supply for two main reasons. One was for the 24 volts DC that it provided, and the second one was that this was DIN rail mountable, both of which are industrial standards that I wanted to include in this build. And now for the brains of the operation, the Controllino Maxi. The main reason for choosing the Controllino is because of its industrial capabilities. Things like vibration resistance, hot and cold temperature tolerance, and of course being able to handle high voltages. This means that the Controllino is an absolutely perfect pick for mission critical tasks in harsh environments. Because the Controllino will be well over 50 yards away from any sort of Wi-Fi source, a radio module transceiver is going to be required. I was drawn to this particular module because of the RS-232 and 485 ports, which means that this particular module can be used for both Falco and any other appliance that uses RS-485 communications. And yes, I did say yards, because this is America, and we talking freedom fractions. Okay, fine. For you metric sympathizers out there, that is the equivalent of about 9.504 kilo feet. Then last but not least, our relay board. Made by Electronic Salon, this board offers 8 individual relays that have a 10 amp rating. It also has 24 volts input, which means it's compliant with our complete architecture. Well, I think it's time that we get down to building something now, shall we? now we've got our physical box completed with both the 2 bulkheads for the outputs and 1 for the input for the AC voltage. And of course, we also have our 4 studs that are going to hold up the board on the inside. All of these things have had JB Weld applied to them to make sure that they don't come out and that they contain the water resistant factor. This is an IP67 box, so drilling into this actually doesn't make it IP67 anymore. But what that means is that this is going to be much better in terms of watertight seal, and so it's going to work. And of course, I know you're all interested to see the end result, but here's one thing we must talk about first. In the next section, I will be working with mains power, and if you are following along with this or doing this in real life, you need to make sure that you're being very careful with this. Mains power is very powerful and could technically kill you, so please consult somebody who's an expert on this if you feel uncomfortable with anything you're doing. If you are doing any wiring, always disconnect it from main power and do not have it plugged in while working on it. I would hope that that's just kind of known, but hey, safety matters. Now that we've got the box completed and the wiring done, let's talk a little bit about the software and the industrial tenets used in its design. I had 5 major tenets that I really strived to achieve when designing this whole project. They were the power seal, the dead man switch, data integrity, closed loop configuration, and deterministic framing. Having a delay on startup is actually very important because the Controllino, when it powers up, actually sends an acknowledge signal to Falco. We need to make sure that if there's a power reset, that it doesn't just spam this all the time. It actually waits 5 seconds before it actually sends this acknowledgement, therefore avoiding any sort of noise that's going to be happening over the LoRa network. Next up is the dead man switch, and the point of this is that the Controllino will turn off after a certain amount of time if it hasn't heard from Falco. What it will assume is that communications have been lost and I should not be running any longer. This can be seen inside of this matrix, where it has the Controllino channel that is outputted, followed by the amount of time that that channel has been on, and whether or not it has received an acknowledgement from Falco. We want it to behave like this because if Falco goes down, we don't want the Controllino making its own decisions. We want Falco driving the behavior, and the Controllino basically to just control the outputs. So yes, it is very underutilizing the Controllino, but at the end of the day, I need this stuff to fail off and not stay on permanently. Next up is data integrity, and this kind of pairs a little bit with the deterministic framing. Underneath data integrity, there is the CRC8 checksum. Now what this is doing is it's having it where there's a little bit of a math problem that the Controllino needs to do to make sure that the information that has been sent over actually adds up. In order to see this particular math problem, we need to look at the way that this has been framed up. What it will do is it'll compare the AA to the CRC, and the CRC being the cyclical redundant check. And what you want to see here is that AA, or the beginning of the message, and the CRC are actually the same. If those two match up, that means that we have data integrity throughout the entire thing and that things haven't been flipped. This is definitely oversimplifying the CRC8 protocol. However, without jumping into absolutely excruciating detail, this conveys the general idea. Number 4, closed loop configuration. The closed loop configuration, or positive acknowledgement, is a method of saying anytime that Falco sends out a message, it better receive a message back from the Controllino saying, I heard you loud and clear, I'm going to do this. If we don't have that, what we have is just Falco blasting commands out into the middle of nowhere and hoping that the Controllino had caught them. How do we know that they were caught? How can we do any sort of error proofing if we don't have that knowledge back? This is critical in making sure that our system works on the industrial level. This is handled by our void send packet function, which will be sending the data exactly the same way that Falco had sent it to the Controllino, right back knowing that everything is safe and sound. All right, we're almost out of the nerd stuff. So number 5, let's see how fast I can do this. AA is the beginning of the message. ID is the device it's being sent to. Type is a subset of the message type. Channel is the channel that we want to turn on. State is what we want it to do. Payload is not being used. CRC is the cyclical redundant check. And BB is the end of the message. And that concludes the industrial tenets for this project. Let's go put this thing in the freezing cold and let's go test it. So the best place in the lean-to that I've got to install this is going to be next to one of my exterior outlets, and of course I got generators and other things that can plug in here. So this kind of fits right there. Now that we've got everything hooked up, let's go ahead and test this thing out. We'll go ahead and change up the database and we'll see if this thing fires off. And as you can see at the bottom here, I have number 4, which in our devices is actually the tractor heater going off today at 8 to 9. All I have to do is just tell it to turn on and turn off, and boom, we're done. Oh, I love being in control of my own automation and being industrial. So let's go ahead and run this test. Well, now that we know that it works, we can finally close this up and we can just be done with this. it's really cold. If you liked and enjoyed this video, I'd appreciate it if you'd give me a like and subscribe. And as always, I'll see you next time. If you like this sort of content, but need more, consider going over to my Gumroad profile and signing up for the Struct Build Supporter Access. When you sign up for the Struct Build Supporter Access, you get notifications of any time that I drop any sort of tech manual or schematic on any project that I am currently doing. At this time, it is completely free, and if you'd like to support the channel, feel free to name your own price. However, it's completely free, and if you'd just like to be notified of when I put up some sort of technical documentation, please consider signing up today.
Now that's what I'm talking about.